A reminder before I start this lesson, this is a video, so I may not take the same time to pause that I would in class to give you a chance to write down everything on the slide. You can always just pause the video if I am making stuff disappear from the screen too quickly, right? Today's lesson is going to be about the quadratic formula. As that name would imply, this is going to be a formula that we can use to solve out quadratic equations. The formula itself is all this right down here at the bottom of the screen. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. However, it is important to still notice the information that is given before that. Specifically, notice that this equation is set equal to 0. This is different from completing the square, right? With completing the square, we just got done talking about how we'd want to move the c value to the other side of the equation so that we could then add our own numbers in there, our own constant in there with b over 2 squared, all that sort of thing. Quadratic formula is back to what we had originally learned with solving by factoring, that we want it specifically equal to 0, meaning you want everything on the same side of the equation. Doesn't really matter whether you move it to the left side or the right side, as long as everything is on the same side, right? Once you have everything on the same side, then you can go about finding your a, b, and c. Once you find your a, b, and c, the rest of it truly is just plugging into the formula, and as long as you plug into the formula correctly, you should be fine. Do make sure you recognize that a, b, and c are all just going to be numbers, right? You are not plugging x in along with them. When you go to plug in b, you don't plug an x in with it. When you go to plug in a, you don't plug an x squared in along with it. A, b, and c are just numbers. You should never be plugging in anything except numbers into the quadratic formula, because obviously that'd be hard to solve out otherwise, right? So using this formula, we're going to go through a couple examples here and solve out using the quadratic formula here. So we will use for our first example, let's say I gave you 3x squared plus 8x is equal to 35. Well, right off the bat, this is not equal to 0, right? So we have a little bit of work we need to do. Technically, we do have the choice. We could move everything to the right side, which would require us to subtract 3x squared and subtract 8x. Obviously, I think the easier and more efficient way to do this would be to just subtract 35 to the other side, giving us 3x squared plus 8x minus 35 is equal to 0. Now that we have this equation equal to 0, we have everything on the same side of the equation, we can go ahead and determine our a, b, and c values and start plugging into the formula. Looks like we'd have an a value of 3, a b value of 8, and a c value of negative 35. So, if we look at our quadratic formula, we've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm truly just going to plug in our three numbers for that. Negative b, well, if b is 8, the negative of negative 8, or the negative of 8 would be negative 8 plus or minus the square root of, again, our b value of 8 squared minus 4 times our a value of 3 times our c value of negative 35. All of that then is being divided by 2 times our a value of 3. Couple things here that I want to point out of common mistakes that get made using the quadratic formula. One, please recognize that if you are taking your b terms squared, that is always going to give you a positive number. It doesn't matter whether I take 8 squared or negative 8 squared, I'm still getting 64 from that. Other thing I want to point out, please notice that this fraction bar is covering everything. everything is being divided by 2 times 3. It's not just the stuff inside the square root. Both the negative 8 out here and the whole square root is being divided by 2a, or in this case 2 times 3. Those are the two common mistakes I see being made. May still get made anyways, but at least I warned you. Trying to solve this down. Main goal is we want to try and figure out what that square root is going to give us. Is that square root going to come out nicely? Is it going to actually square root evenly? Are we going to have to do a factor tree to try and simplify it further? Is it just going to be a prime number? That sort of thing. So for now, I'm just rewriting the negative 8 inside the square root. 8 squared, like I just said, would be 64. If we have a negative 4 times a 3 times a negative 35, if that's how you want to look at it, or you can look at it as a positive 4 and just leave the minus there. I prefer to look at it as a negative 4. If we take negative 4 times 3, that's negative 12. And if we take negative 12 times negative 35, first off, a negative times a negative is a positive, so we know we're adding. And then we'd get 420. 2 times 3 on the denominator in the bottom there is 6, so I'll go ahead and do that as well. Next step then, I'm still trying to simplify that square root down to a single number, so I need to take 64 plus 420. If we do that, we get negative 8 plus or minus the square root of 484. All of that then being divided by 6. Well, next step then is to see what we get with the square root of 484. So, like we've talked about, you should do the square root first and see if it comes out evenly before you start doing a factor tree and everything. In this case, the square root of 484 does actually come out nicely to 22. Meaning we have negative 8 plus or minus 22 over 6. Now this doesn't always happen, obviously, and we'll do another example where it doesn't work like this. But when it does come out nicely, we can solve this out to 2 actual answers, right? Understand the 2 answers that you have here are, we have negative 8 plus 22 over 6, and we have negative 8 minus 22 over 6. We want to solve both of those out. Well, negative 8 plus 22, that's different signs, so those are going to not combine, right? We're finding the difference between those. Negative 8 plus 22 is going to give us a positive 14, which, if we divide by 6, that's not going to come out evenly, but we can at least try and simplify out this fraction. 14 can divide by 2, 6 can divide by 2, so this would come down to 7/3, right? Bad handwriting there. On the other hand, over here, we've got negative 8 minus 22. Those are both negative, so they would combine to a negative 30. Negative 30 does divide by 6 evenly, so we get negative 5, giving us a final answer of x equals negative 5 and positive 7/3. Let's try another example. With this one, we've got negative 2x squared equals negative 2x plus 3. Again, we do not have all of our terms on the same side, and before we can solve out using the quadratic formula, we do need to get this equal to 0. You do have a choice, just like before. You can move everything to the left side, you can move everything to the right side, it's entirely up to you. For me, as I've said before, I always prefer to have a positive a value, meaning a positive number in front of the x squared if I can. So I would probably choose to add 2x squared to the right side of the equation, giving us 0 equals positive 2x squared minus 2x plus 3. To be clear though, it's entirely up to you. You could leave it as negative 2x squared, add the 2x over, and subtract the 3 over. You will have different numbers than I do to plug into the quadratic formula, but it will still give us the same answers at the end either way. It truly does not matter. For me, I have this equal to 0, so it'd be time to establish my a, b, and c values. I have an a value of positive 2. a b value of -2, and a c value of +3. So when I go to plug this into the quadratic formula, I'd have x equals the negative b value, well, the negative of -2 would be +2, plus or minus the square root of my b value of -2 squared, minus 4 times our a value of 2 times the c value of 3. And all of that, again, remember, all of this is being divided by 2 times our a value of 2 as well. Again, just like the last example, my most immediate goal is to try and get that radical down to a single number and see what I can do with that. Well, in this case, that means we'd have the square root of +4. Again, remember, any number squared becomes positive, so -2 squared is still a +4. And then I've got -4 times 2 times 3. Well, -4 times 2 is -8. -8 times 3 would be a -24. And then all of that is being divided by 2 times 2, which is 4. 4 minus 24 would give us 2 plus or minus the square root of -20 over 4. Well, I noticed two things here. First off, I noticed that I'm square rooting a negative, so now, using our knowledge from past sections, we know we're going to be introducing I to this problem. Along with that, I also notice that I have the square root of 20, and 20 is not a number that square roots perfectly. So I am going to need to simplify this, and the way we know to do that would be to use our factor tree. So if we think about the square root of 20, you can choose whatever two factors you want. I'm going to use 4 and 5. And we know 4 square roots perfectly to 2, or we get 2 2's out of that. So 20 simplifies to 2 square root of 5, which means then if 20 simplifies to 2 square root of 5, then -20 simplifies to 2i square root of 5. Remember, the only difference between square rooting a negative number and its positive version is that we have I. But do make sure you also remember that I has to be outside the radical. I itself represents the square root of -1. So what we're really doing is with this factor tree, we've got the square root of -20, and we're breaking it into the square root of +20 and the square root of -1. That's where we're getting I from. So you need to have I outside the radical because it already represents a radical itself. All of this is still being divided by 4. Now, obviously this did not square root perfectly, so we're not going to be able to get to single numbers for our answer like we did on the last problem. However, this would still not be our final answer. Understand you are looking at 3 terms right now. 1 term, 2 terms, 3 terms. That's how you should be viewing this. There are 3 parts to this. If you look at all 3 of those parts, all of those 3 parts can have a 2 pulled out of them. They can all be divided by 2. So the simplest version of this answer would be 1, 2 divided by 2 is 1, plus or minus 1i square root of 5, because 2i divided by 2 would just be I, over 2, because 4 divided by 2 is 2. And then we'd have a final answer.